Or do you want me? Oh, perfect. Thank you. So if you don't have a link to the website, hopefully one of the organizers can share it again. But this is going to give you a gist of what we'll be covering today. So if we scroll down to the schedule, we're going to run the series in 4 parts. So this is actually a 2 full-day workshop. So it's actually 2 8-hour days or more. And we're trying to cover all of that in 4 evenings, which is pretty ambitious, I would say. So we're probably not going to be able to cover every challenge and every detail. So I wanted to provide you this website so that you can go back to it and revisit some of the challenges that maybe we haven't covered, or if you wanted to basically get a refresher for what you did in the last 4 parts, this is going to provide you with link. So today we're covering part 1. So today is really just a let's get everyone to the same level kind of day, where we will orient you to the RStudio IDE, which is the interactive window for R, and also just the basics of R. And then in the next 3 evenings, we'll be doing more heavy duty coding. So today it's just an intro kind of day, so it's very laid back. And you can click on all of these, but honestly, I just wanted to let you know where the resources are, so that you can follow on your own time. But just, you can just look at my other screen for now. So here is the Posit Cloud. So if you logged in, this should kind of be, this should be what you see. So if you logged in, and this is not what you see, can you please put up a red sticky or a red emoji? And if this is what you see, put up a green sticky.
Yuka, can you remind people where the reactions are? I think they're at the bottom.
Yeah, if you click on the reactions button, you should be able to see like a green check mark or red X. I have a hard time seeing all of you at once. So if the organizers, you guys see anyone who has the red sticky up, can you let me know?
Okay.
Awesome.
Yeah, I see 14 green check marks right now.
Cool. Okay. So this is Posit Cloud. So this is like our studio on the cloud. So there are different ways of interacting with R. Normally you would download the R program and RStudio program, but today we kind of wanted to skip ahead and make sure that everyone is able to actually start R and just get running with it. So this is just something that's freely provided by RStudio, but the limitation here is that you can only compute for X number of hours and use certain amounts of memory. So this is not really where you want to work in. This is just like to give you a good experience coding. So I want you all to start a new project. So hopefully you can see my cursor and click new RStudio project. And it should be deploying and thinking about what to do. Doesn't take very long. All right. So this is RStudio. So when you have RStudio, the program open, this is exactly what it's going to look like, minus this thing on the left and like the workspace name. So you should see 3 windows. And what we want to do next is actually open up 4 windows. So do you see this double box here? Click on that, and another box should open up. Hopefully everyone can see this. Okay, so you should have 4 windows. And it's a little confusing, like where do we code, what's what? So I'm just going to talk about each window one by one. So I'll start from here. Well, no, let me start from here, the bottom right corner. Hopefully everyone's screen looks exactly the same. So when I say bottom right, it's bottom right on your corner too. So this is something that reflects your computer. So this is cloud. So it's on the cloud. So everyone's cloud projects should look exactly the same. But this essentially will show you, where your folders are, your desktop, all that kind of stuff. You can interact with it. You can, create a new folder, whatnot. So this kind of reflects what's on your computer. And on the left of that, you should see our version, Beagle Scouts. This is actually where our executes code. So for example, I want to do 1 + 1, and I hit enter, it should tell me 2.
Can you
And
your text size slightly? Maybe zoom in 1 or 2 times. Yeah, I think that would be better.
yeah, thanks. Is it big enough now for everyone? All right, okay. So yeah, so when you type 1 + 1 and I hit enter, you should see 2. But the thing is, I can keep doing a bunch of stuff here, but then it'll go away and I can't keep a record of what I've done. So this is why there's this additional window on top of it. It's kind of like your notebook. So for example, I can say 1 + 1, and there are different ways of running it. So up here, it's just a notebook. So it's just what you're writing. So it's not really computing anything here. So let me just clear this. So if you see this like invisible broomstick, it will clear your screen. So I can highlight this, and I'm on a Mac, and I don't think it matters if you're on a Mac or Windows here. So if you hit Command Return, it should automatically pop up down here, and it will execute your code. Is that working for everyone? Yeah. Green check marks. If it's working. I'm assuming everything is okay because I can't see anyone. Right. So what if I wanted to run this? So maybe I should go over all the ways you can run code because it's actually quite confusing sometimes. So let me go make a third line here, and I'll do 100 + 2. And then I'll create another one here, 50 plus, or let's do ×2. The multiply is the asterisk. So I've typed everything here, but nothing is being executed. So what I can do is, you can see that my cursor, I'm jumping down to the third line now. From here, without highlighting anything, I can hit Command Return, and that will run. Or the other way of doing it is for me to highlight this and hit Command Return to run this particular code. Or I can also highlight everything and run all 3 lines of code. And if I haven't lost you already, there's 2 more ways of running code. So do you see this run button? And then there's this, where's the other button? Is it just run now? Ah, thought there used to be another one. So the other way you can run it is by hitting run. So this is kind of equivalent to your Command Enter. So if I highlight this, I can hit run, that will do its thing. I can also, just have it blinking on line 1 and hit run, and it will do that. So when you see me executing code and I haven't really clicked on anything, that's mostly because I've used the Command Return symbol. It's just a nice shortcut. Sometimes something might happen. So let's say I'll do 2 plus, and I accidentally run this code. So I've run this code now, and it's no longer prompting me with the greater than symbol. So now it's R actually realizes that your code is not complete. So it's expecting something to be followed by this plus sign. So what you could do is then complete it, say 3, but highlighting 3 and just running 3 on its own, then you can complete this code. Or let me try that again. So we can do 100 divided by, and I run this line. What I can do now is say, okay, you know what? Like I've, bashed my keyboard. I don't know what to do. It's just not letting me code anymore. What you could do is then come down here to the console, click on the console itself, and hit the escape key. So if you hit the escape key, you should now see the greater than symbol blinking again. So the greater than symbol is now expecting you to give it a brand new prompt. The plus symbol indicates that it's expecting something to be continued. So that's something to pay attention to while you code as well. And so you can come up here and you can fix your code. Let's just make it all happy, because otherwise everything's going to yell at me. And yeah, can compute properly. So you can do basic arithmetic. This is the very, I would say, basic function of R, is you can use it as a calculator. Obviously, there's much more you can do, but just so I cover all the different arithmetic, you can do 1 plus or 1 minus 0. We covered multiply, we covered divide. What else is there? Exponents. So exponents are these carets. This upward arrow triangle, they're called a caret. You can do 2 to the power of 2. You can get 4, or the alternative, if you are a Python coder, you can do a double asterisk, which will also give you the power. You can also enclose things in parentheses. So the circle, the rounder brackets. So we can say 2 plus 5, then multiply this by 1. Let's say 10 minus or 10 divided by 2. And it will compute just as you would, back in your school days. So R also shows very small numbers very differently. So if we did 2 divided by, I don't know, lots of zeros, lots of a big number, you can see, I guess that was a million, that your answer is in 10 to the power of negative 4, so that, or negative 6, I guess. So it does, it shows you in scientific notation when you have very small numbers. And you can also provide notation like this as well. So 5 to the 10 to the 3rd power gives you 5,000. So these are very, very simple things you can do with R. The other important things to know are something called Booleans. So Booleans are true or false statements. So these actually come very handy when you are doing more complex things. So I will apologize. So the beginning might be a bit dry, but these are really good fundamentals and terminology to learn as we get more complex later on. So a Boolean, so we can say does 1 equal to 1? So there are 2 equal signs here. And this compares 1 to 1. So is it true? Yes, it is. And if we say 1 equals to 9, it should say false. So what if we want to compare something that is opposite? So if one does not equal something, so that is we used a bang sign. So the exclamation mark is called bang. So it's also referred to like as a negative. So it negates your statement. So not equal to 0. That's true. So 1 does not equal to 0. And if 1 does not equal 1, that would be false. And again, you can do like other comparators, like greater than, less than. So is 1 less than 0? False. Or greater than or equal to 0? False. And you can do, what else can we do? Can't think of anything else right now in terms of Booleans, but just keep this in mind if we can come back to Booleans later. And the other thing I want to share are variables. But before I go into that, I want to introduce you guys to a more, I guess, efficient way of coding. So here we've kind of typed out a bunch of different things. And, you know, if you were to come to this 2 months later, you're just going to see a bunch of code and it's not going to make sense. So we need to be able to take some notes. So to be able to take notes, you want to use this hashtag or sharp symbol, and your prompt should turn your, I guess, your script up here should turn green. So this is a comment. So if I were to highlight this and try to run this, it just says hashtag, this is a comment. So this R can understand that this is not a code and it's just like a note for yourself. So I want to suggest that you take notes like these types of comments liberally. So for example, if I, you know, this set of code isn't working, I can, I can't, how do you comment things out again?
Command Shift M.
Organize. Command Shift M.
Oh, C,
Nope.
sorry. I'm thinking of the pipe. Command Shift C.
Yeah, I use a different IDE, so the shortcuts are different. Anyway, so the answer was Command Shift C for comment. You can highlight and comment everything out. So now this won't run. This is useful if you kind of want to take away code, but you don't necessarily want to delete it, but you want to kind of save it for later. You can save this because you can also highlight it again and re-hit Command Shift C, and it should come back as code. So this is a little neat trick that you can use. So right now, let's start coding on a, what is it called? RMardown. What we want to do right now is let's just save this. So if you guys remember what a floppy disk is, we're going to save this to a floppy disk. So you hit that mark there, and let's just say, let's create a folder called scripts. And we want to save this in as my first script.r. And hopefully you see that on your bottom right hand side as my first script.r in your R projects. Okay, so if you've saved this, we're going to open up a R Markdown document together. So, okay, so what I just did was we're going to click up here with the green plus sign. Hopefully everyone's still following me. Green stickies all around if you're good, everything's saved.
pretty good. We have 10.
Yeah. All right. Okay, so we're gonna hit this and you'll see a whole slew of things. So even though this is called RStudio, or I'm still calling it RStudio, I guess it's now just Posit. I'm not quite sure what the name is now. It used to only do R, but now you can see it actually codes in different languages. So Python, SQL, Stan. I don't even know what D3 is, but it does that. But today, so what Posit now can you do is that you can actually use this to code in different languages, but we're focusing on R today. And what I want you to open is the RMardown document. So click on that. And you should see this prompt. It says installations required. Do you want to install these packages? Say yes. You'll see the console download a bunch of stuff. It should be relatively quick for everyone. And once the installation is done, you should see this window come up. So now we want to create a new Markdown document. So that we only needed to download it once, because once it's on our computer, it's there forever. So you won't see that whole download thing again, but the next time you click on R Markdown, this window is supposed to come up first. So let's name this, so intro to R part 1, and the author, you should put your name, not mine, and keep HTML clicked and hit OK. So now you should see a bunch of stuff being written into your scripts here. So this is called a Markdown document. Markdown documents have different components. So it's easiest if I can show you why, like the finished product, so I can explain to you why this is useful. So everyone, if you can click on the knit button here. Let's name this, what should I name this? My first R Markdown .rmd. So R Markdown documents end with .rmd. I think it might automatically give you that if you don't write it down. So you should see a new window open. It's a new HTML document. So this looks like its own website. It's like on a whole complete document that you can share with people. It's, you can open this in your browser. So I can say open in browser. So I have my Chrome opened. And essentially, this document is shareable. So what you can do is, come back to your document, and in my scripts, I have this HTML document. I can download this and just like email it to someone, and they will have this document open. And this is really nice because then you can, do your analysis and share your code with your boss, your coworkers. If you have nerdy friends like mine, you can share them with your friends. But essentially, this is a completed document that's produced by code. So let's compare what the R Markdown showed versus the finished product. Let me make this smaller. Okay, so the first component we want to look at is this from line 1 through 6. So you don't want to get rid of these 3 dashes because this kind of like tells you where this important information goes. So essentially, this is your title, author, date, and output type. We are gonna skip this. We can just ignore this for now, but move on to this part. These have 2 hashtags. So this actually is the title. And then you see a bunch of notes. You can see that this link was in the, I guess, this less than enclosed by these like less than, greater than symbols. It denotes a link that you could click. You can also see that this double star creates a bold text. And then this is a chunk of code. So this summaries, you can actually run this. So if you were to come down here into your RMardown and hit Command Enter, you'll see the code execute both in your window up here as well as in your console down here. So basically it says, hey, this chunk of code is an R code, and this is the title of my code, and this is what I'm computing. So I can even add code here, say 1 plus 10. This is something that we tried earlier, and it says 11. But before we knit this, let's talk through different things. So here, there's a plot that R has created. So plot pressure. So pressure is a data set that's been provided to you automatically. So it just plotted the pressure by temperature. And it says echo false. So what does that mean? So if you compare the difference between the cars code and the pressure code, there's actually something that's different. So can anyone figure out what echo false is doing here? Feel free to unmute yourself, because if you're raising your hand, I can't see it. Anyone?
If anyone has used like shell scripting before, you might be able to guess what echo equals false could be.
So like the word echo is like echo, echo, echo. It's like says the thing right back at you, right? So if echo is not false here, so the R for cars, it's not false. So you can assume maybe it's true by default. So here you can see that summary cars is shown. So it literally echoes or shows you what the code was, as opposed to the pressure. Echo was converted to false. So you actually don't see the code. So depends like how you want to share a document. You can kind of, if you're sharing your document with someone who doesn't really like code, or looking at the code itself is not very helpful, and you just want to show them plots, you can put echo equals false, and you won't see the code itself. Oh, the answer was actually right here. The other things I want to show you, so there's these two hash marks. So we can say, actually, the first hashtag is actually going to give you a very large, so it goes by hierarchy. So this is going to be the biggest header. So we can say header 1. And this will be header 2. Whoops. Maybe I'll just say header, 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 header 2. And this is header 3. And earlier I said these are comments, but this is not the case in R Markdown. So R Markdowns are special because it can create that document. And that earlier script, so anything that ends in .r, like this document that we created, the hashtag symbol actually acts differently, because you can't actually knit it to a document. Whereas this one, when I hit knit now, I should see this get re-knitted or re-rendered. And you should see, so header 1, 2, 3, and then I added this extra code here. 1 plus 10 equals 11. and so on. So what I want to encourage you guys to do for the rest of today and for the next several workshops is to try to continue coding in Markdown, because at the end you can actually have a nicer product to look back on, and you can take notes more liberally, and you can see what's code, what is not, much easier, and you can kind of get a hang. You can get more practice working in R Markdown. And again, I think this is probably one of the more useful ways of coding because it's shareable. For example, like I mentioned earlier that I code as a student, and when I share my results with my boss, I actually keep everything in Markdown, and I knit the document so that he can see like the plots that I create and the analysis that I produce in a way that I can share with him and he can keep on his end. And so this is just a very nice, tidy way of maintaining your code. But if you don't want to, no worries, you can keep working in our script as well. But this is just a little mini challenge that I want to pose to you. Okay, so let's create a new R Markdown, because I kind of butchered this one already. And we're going to call this Intro to R Part 1. Oh. This has the same title, but it's okay. It's a different document. So maybe I will save this as in my script. So I just hit the floppy disk. This is part1.rmd. So it should show up here. So what I'm going to do now is to kind of get rid of everything. So now my document is blank from line 13 onwards, and my title here is going to be variables, because I want to introduce variables to you. So what are variables? Variables are kind of like buckets that store data. So let's create a code chunk. So you can hit this plus sign here and hit R, and you should see this come up. So this is a code chunk, and this is where you can produce code. So let's say we want X to hold the value 10, and we run this code. Let me do that. It runs the code, nothing happens. Now let's do Y equals 1 plus 100 and run that. It does nothing either, but it's not giving me 11 or 101, which is what I expect. And that's actually totally fine. That's what we want it to do, because we want these variables to hold value for us. So we don't have to keep repeating the same values over and over again. So we can then use this to compute. So we can say X plus Y equals 111. So it's not until, so when we assign things, so this less than followed by a dash is an assignment operator. So we're assigning the number 10 into the variable X. So that's what's happening here. So when we assign stuff, we're not asking it to print anything, print the answer out. So that's why, it stayed silent. So when you're coding and nothing is happening, it's probably because you've assigned it. So, and it's R just will do exactly as you say. It won't try to assume that you want the answer unless you tell it I want the answer, as I did down here. You also may see if you are familiar with coding in other languages or have seen R script from other people, they may use a different assignment operator. So we can do the same thing essentially. So let's assign, 20 divided by 1 to A. And to B, we're going to do B equals 1. So I'm moving this here. So A multiplied by B is, you would expect, 1. So the difference here is that now instead of using this assignment operator, we're using a single equal sign. So this is different from the double equal sign. The double equal sign compares things, so true or false, like Booleans. Whereas the single equal sign is an alternate form of an assignment operator. Depending on who you ask, it's the more popular form because other languages use it. So this particular assignment operator is specific to R. So you'll know if people use this that they probably favor R. And if people use this, they probably know how to code in Python or something else. And the reason why you want to, so this is, for the most part, mostly interchangeable. So you can use either this or this, except in certain cases, which whoever is covering functions may cover it in part 3 or 2, I think 3. But it's not always interchangeable. But when it comes to assignments, they are. And you'll see that I favor this one. So if you want to follow along and code with me, you'll use this. Okay. So the first challenge I want to pose to everyone is on the collaborative notebook. So if we go down here to page, oh, pages aren't numbered, page 2, you'll see the first challenge, which is which of the following are valid R variable names? So you can stare at it and figure it out, or you can try it out. So for example, we can take this, copy it. I'm going to copy the whole thing over here so you can see. So challenge 1, which of the following are variable valid names? I'm going to create a code chunk and we can test things out. So we can say, hey, is this a variable name? Let's assign it 1. I don't see any angry red stuff. Probably okay. Oh, I guess I didn't introduce this upper right-hand corner, which now becomes more useful. You can see that I have A, B, min, height, X, and Y. It basically shows you all the variables that you've assigned. So this is kind of how you can start keeping track of all the different things that you've created, which is really convenient and helpful. So you don't have to, read your code and try to figure out what's what. So give this a try for all of them and trying to think about why certain variables may not work. And when you're done, go back to the collaborative document and put your name underneath. So like so, when you're done, type your name and I'll give you guys like under 5 minutes to give this a go. And if you have any questions, put up a red sticky. And or you can unmute yourself and ask me a question directly because I can't see everyone's sticky at the same time.
I have a question about the little dash 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 squiggly R squiggly thing. What is that
Yeah.
for? I've never seen that before
So this,
in a script, like R script.
yeah, so this is a very specific thing to a markdown. So this tells you it's an R script. So for example, if I come down here and I want to put together like a Python script, it actually says dash 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 Python. So it says code starts here and ends here. And what type of code this RStudio, or posit, sorry, I'm still gonna call it RStudio, is gonna interpret this as our code. So that's what this means.
Okay,
And
so everything that I want to code has to be within those 2 lines, basically.
yeah.
Okay.
And the other thing is, so for example, you have a sentence and you want to put like a little chunk of code in the sentence. For example, let's say here I have an example of adding A to B, and the answer is, and I want to have it display right there. What you can do is do a single backtick. So these are not apostrophes, these are backticks. So this is on your keyboard next to your number 1. And you can say A plus B, and that will then interpret it as code and we'll leave it there. So let me just net this document to show you what I mean. So I guess I didn't say what A and B were.
Right, but that makes sense, yeah.
Maybe that will work.
Yeah, I think you need the R.
R, yeah.
Oh, I see.
Yeah. So you need to tell it what kind of code it is. Otherwise, it will interpret it as like code to echo, if that makes sense.
Formats it as code, Yuka.
Yeah.
Okay, thanks.
Yep. Okay. I haven't actually kept track of time, so let's assume that 5 minutes have passed and try to go through the challenges together. So I already showed you that min height probably works, and it doesn't give me an error. So, and it says 1 here, so A, it works. Does anyone know if the second one, max.height, is that going to work as a variable? Anyone?
People are putting in green check marks.
Oh, okay. So that's going to work. All right, let's do that together. Let's say this equals 10. Great. All right. Underscore age.
I'm seeing some red X's.
Red X's. Okay, let's give that a go. All right. So now we know underscores don't work. All right, let's keep that in mind. So that is actually kind of an important thing to know, is that R does not like symbols. So if we were to do, and for some reason, like a $, because we're cool, and we want to say $, I don't know, maps. that won't work either. So no symbols at the beginning of the variables. But what about dot mass? What do people think? Some green check marks, one red. So that didn't throw a red thing. Nothing red, but at the same time, I don't see mass over here. So this is actually kind of a trick question because the dot actually hides your values. So the dot makes it kind of invisible. So you actually can't see it. So it actually does work, but you're not able to view it. So I haven't actually come across a time where I wanted to do this. So I tend to avoid it and use variables that I can see in my global environment. Okay, next is max length.
Can I ask
We
a question?
think, yeah.
If you hide a variable, how do you find it? Like,
How do you find it? All right, let's say we've hidden mass 10, and to show all your variables, the function is called ls. ls open parentheses, close parentheses, and you can run that. And that actually doesn't show you what you need to know. So what we could do is we can go to the help function. So to get help, you can either type help ls, but ls has to be in double quotes, or the easiest way is to do question mark ls, and you'll get this help function on the right hand side. So you can see this description. How do you use it? And I'm assuming here it says all names. If true, all objects are returned. If false, names that begin with the dot are omitted. So let's use that to guide us. So we'll do ls all dot names equals true. So it tells you how to use it because I know how to use it because it gives you an example here. So these values here are kind of the default settings that it has. So we can do ls names, and then we can see everything that's created, including this hidden value. I actually don't know how you can display it up here. If anyone knows, let me know. I tend to just use ls to check when I'm creating variables. So hopefully that's useful. Any other questions? Nope. Okay. All right. So is min dash length a okay variable? No. Why not? Anyone want to take a guess? You can unmute yourself.
Maybe
R.
R. Oh, sorry.
No, sorry, go on.
Oh, I was just gonna say maybe R thinks that you're trying to subtract the length from min. Is that what's happening?
Yeah. So this is very specialized. It's a arithmetic function. So that's why you can't do dashes, but you can do underscores as in the middle. So we couldn't start with an underscore, but we can have underscores in between. So we can do underscore instead of the dash, and that will work. Would this work? Two widths I see head shaking. So no, you can't. Again, it's because R does not like things other than characters or letters to start a variable name. But you can do capital letters and lowercase letters. And I should note that R is actually quite sensitive. So before I explain that, let me comment these guys out. So that's Shift Command C to comment this out. So you saw those like little red X's on the left-hand side. It tells you there's an error in your code. I just want to X those out because it's going to create an error when I try to knit the document. So I'm going to X these out too. What I want to do is I'm going to show you this example. So Celsius to Kelvin will say this equals, oh, I've been showing you how to store numbers, but you can also store characters. So you can store temp, the word temp and Celsius to Kelvin. And we can also, let me copy and paste this and make this lowercase Celsius to Kelvin. And I'm going to put that. So when I print this, so how do I print stuff? So we can say print, or we can simply type this. So this will say the same thing as this. You'll see this and this are interpreted differently. So R is case sensitive is what I want to demonstrate. So if you store something in the uppercase, you have to remember that it was uppercase, because otherwise when you try to recall that particular variable and use a lowercase, it's going to say, hey, I don't have something with the lowercase c if I didn't have one. And it'll throw an error. So just keep in mind that spelling and uppercase, lowercase are kind of the most common errors that you see. Typos are really the major errors in code. So keep that in mind as you debug your code. This is probably the culprit. Okay. I think we've covered all of the challenges. Great. Let's move on to maybe, you know what, we should clean this up. So there are different ways of cleaning up your code. So right now, my global environment, my upper right-hand corner has a bunch of values. I can do it the clicking way, which is don't do it, but I'm just going to show you, but don't click it. Is this broomstick. I can click on that and it will make everything disappear. Or I can use a function. So I can say listing all variables. We learned this. We can list stuff, list variables by a certain thing. So we can say we can list by the ls, which is what I showed you earlier. And we can remove individual variables and do that with rm for remove. So remove is another function. So whenever you open a parentheses, so you can say whenever I type the first one, the second one, the closing parentheses auto completes, which is really nice. So you'll notice that functions are always denoted by these open and close parentheses. This tells you this is a function. So in here, what we want to do is say, let's remove the variable Celsius to Kelvin with the lowercase. So I'm going to run that code. I see that disappear. And if I try that again, it says, warning, object not found. So it's because I've already erased it, so you can't erase something that's not there. So what if I want to remove everything? So let's say this is a two-parter. Oh, so within your code chunk, you can still comment. So this is remove single variable, remove everything. So we can remove everything by rm, open parentheses, list equals ls. So what this is doing is, remember what ls on its own does. So ls on its own tells you everything in your environment. So I'm just going to run this code up here. So ls gives me all of this. So I'm basically plugging in all the answers from here within this remove function. And if I run this code, now my environment is completely empty. So here, if I then try to say, print out what A used to be, A is not found. So I'll throw an error. Hopefully that makes sense. Okay. All right. So the next handy thing I want to share are vectors. So what are vectors? It's a one-dimensional string of characters, you could say. So you could say 1:10. And if I print that out, it gives me 1 through 10. So I say one-dimensional because it's one row of things. This is actually kind of handy sometimes because you can say 1 through, you can even do 10 through 15, and you can multiply that by 3 or 4, and it will multiply 4 against every single object in the vector. So you can do some funky computation with that. Okay. And I have a second challenge for everyone. So challenge number 2. I'm going to copy this and want you all to go through this. Basically, you can either read it and try to figure it out, or you can plug it in to a code chunk and play it out and see what the answer ends up being. And I'll just give everyone a minute to kind of read it, try it out, and we'll answer it together. Okay, so the first thing what I'd want to do is to create a code chunk, because if you remember, this is just interpreted, as code. Nope. It will interpret it as code, but when you knit it, it won't. Yeah. So let's create a code chunk. And here, let's just copy and paste. You can do the hard work and type it all out, but that creates a lot of spelling mistakes. So I encourage you to copy and paste, unless you want exercise for your fingers. So you can say, let's execute all of this, mass, age, and then we'll do mass multiplied by that and age. So hopefully when you print out mass, you should see that it's 109.25. And when it's age, it's 102. Hopefully everyone has the same answer. Okay. All right. The next thing it's less of a challenge, because I haven't taught you this. I can't actually challenge you to do something that you don't know yet. But we want to install some packages. So what are packages? R is R and Python, but we're gonna take favorites and say R because it's the best language. Is one of the most popular coding languages out there, because it's open source. So what that means is that you don't have to pay for it. Anyone can have access to it, which means that anyone can create really cool tools, which also means that you can copy or get access to everyone's tools to do whatever you want to do. And one of the really amazing things about an open source environment is that there's so much development out there. If you want to do something like something very niche, let's say, well, the only thing I can think of is cancer genetics work. But if you want to do something very specific with cancer genetics and you understand what single cell analysis means, there are packages out there that will do just that. If you are I don't know, a geologist and you have GIS data that you want to analyze and it's a whole bunch of like coordinates, there are tools out there or packages out there that specialize to handle these kinds of very special topic niche things. So packages are really handy, and they are not automatically, all the tools in the world that are available to R are not automatically installed on your computer, mostly because they will probably break it. Unless you have a very expensive laptop with lots of memory, then awesome, good for you. But not everyone does. If you have a tiny laptop like me, my computer will cease to work and I won't be able to do anything at all. So by default, nothing is installed. Only the basic base R functions are installed on your in R. So you can take a look at what you have right now. So let's open this up, hit packages. So you can see that base R is clicked. So that's the basic stuff that comes with R when you install it. There's some other stuff here that are kind of like nice to see, but not everything that's available is actually in here. So what we need to do is to install a few packages that we'll need for the rest of the series. We'll do this now because I have some other things that I want to talk about that I can talk about while this whole thing installs. So what we'll do is let's, do I want to do this here? Okay, sure. Let's install some packages. So the packages that we're going to install are called, well, the function to install packages is install.packages. It's very intuitive. It's awesome. And another trick I want to show you is, let me kind of go back. And when I typed in install pack, you can see that this little thing comes down and says, hey, do you mean to install packages? Super handy. You can choose to click on it, or you can hit the tab button, hit tab, and it auto completes. So this is really helpful. I tab complete pretty much everything. So you can tab complete. So for example, up here, I have, a variable that I named called Celsius to Kelvin, right? So RStudio is pretty smart. You can say cell and then hit tab, and it will autocomplete all the variables that are currently in existence in your script or Markdown in our case. So tab complete is your best friend. Use it. It will prevent lots of typos. So anyways, going back to installing packages, we want to install a few packages. One is called ggplot2. The other one, you're just going to copy and paste. You're going to install dplyr. And the last one is called gapminder. And let's just highlight all of this and hit run. And if it's working, you will see all of this stuff. And that was super quick because we're on the cloud, I guess. It would have installed everything for you. If it says error, put up a red sticky. We'll get this sorted for you. So ggplot2 we're not going to use today, but we will use later. This is a really cool package for plotting. It makes these very beautiful graphics that are publication quality. dplyr is a really useful tool to manipulate big data. And gapminder is a package that contains data that we'd like to analyze in the future. So probably in the next lesson. And so what I wanted to talk about is something that was going to take some time while this was installing, but now it won't. But I want to talk about how the best way to organize your file system or your directories. So if we go back to files, and let's go back to project. Currently, we have a few things open here. We have a folder called scripts. Another way that I call folders are directories. So directories and folders, they're synonymous. And we have an object called RProj. So it stands for our project. So when you're on your own computer, you can actually click on this and it will call out your local instance of RStudio, and you'll see this exact window. The other things that is actually a nice way to sort your file system is I usually have something called data. I'll just create that here. Another called results. So this is typically how you would want to organize your computer, your file system. So you want to have your data in a certain folder. You want your scripts. So scripts are these things in another folder. And then you want to output your results in another folder. You don't really want to mix all those things up, because then when you open up the particular folder, it's just like one giant mess. So one thing that now becomes important to know is how to navigate in different places to different places. So let's say navigation and recipes. So let's run new chunk of code called getWD. So getWD is a function called stands for get working directory. I find it really handy to know what the actual phrase is because getWD doesn't mean anything. So when I say getWD, it shows me that I'm in scripts, which is here. And that's because this part one RMardown is located in this particular folder. So it tells me this is where I am. Why this is important is because I guess when you save and load data, you want to make sure you're pointing it to the right place. So let's, I might be jumping ahead, but this is really important to understand. I want to show you guys a image. Where is it? It's not here. I thought I put it here. 1 second. Sorry, guys. It's worth it. Worth the wait. Here. So I wanted to show you this diagram. So we just did get WD, right? Hopefully you can see that. Get WD. And here, for this particular person, it showed that they were in their user folder or directory. But for us, we were in the scripts directory. Say like the way things are organized, things in our computer is organized in hierarchies or like in this tree system, for example. So the very, very base of, or the root of your computer is actually denoted by this / and it's actually called the root. That's the very, very, the end. If you dig deep enough, this is where you'll end up. You can't go any deeper. That's the soul of your computer. And then from there, you have different folders. So you have the bin folder data user temp. If you've dug around in your computer, you may recognize these kinds of names. You might have seen them. And then your particular user might be under users. And under user, you'll have desktops. So one way we can do this to demonstrate that is, so for example, let's say list files. And if we do list files and nothing's inside, it will just list everything in the current position, current working directory. So working directory indicates where you are right now. So we can remember we're in scripts. So list files will show me everything in scripts and we can validate that here. But let's say we want to list everything. We want to look somewhere else because we know where we are. So to do that, you open your double quotes. Let's see what's in root. So root is the very, very base of your computer. And there's lots of gibberish, and this is what we expect because this is not where you hang out and you store your data. This is where all the really important stuff go. And I wouldn't mess with the cloud because, it's the cloud and I can't fix it for you. So there's that. So we can take a look, we can be nosy and say, let's look at what's in home. So to do that, does anyone want to spell out what I should put in here? So list.files what should I put in here to look at home? Be brave, mute.
Put /home. I don't know if that's right.
/home. Okay, so /home, like that. Yeah, all right, we're gonna run that. And there's an error. Anyone know why?
No quotes.
Yes, so you want double quotes. So you can highlight and start your double quotes and it will enclose everything for you, which is nice. So let's do that again. And in home, there's this R dot blah, 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 blah. That's probably right. I'm not going to confirm, but that's what's in home. And I just want to mention that this won't work. So home on its own won't work. Does anyone know why this won't work? So what is this code that I have highlighted trying to do, which explains why it doesn't work?
It's trying to list files from the home directory within the current working directory.
Yeah, exactly. So what it's doing, so remember my getwd is in scripts, so it's right here. It's looking for a directory or a folder name home right here, which is why it won't show. So we can kind of play around with that. Let's say, hey, let's just create a home directory and mess with our brains a little bit. We could say home. Oh, there's nothing in it. Let's create a blank file. And say what's in home. Now we have this, but this home is not the same as this home. Just to confuse everyone. And the reason is because it starts with a root. So the path really matters. So the absolute path, so there's two terms that I'll say. There's something called an absolute path and a relative path. And the absolute path always starts with the root. So we'll say list files, an absolute path. Let's see if I can make it here to scripts. Oh, cloud, that's helpful. Oh, so how I'm doing that. So when I have root open, when I type root and I hit tab, it gives me all the options. So again, tab, really awesome button. Hope it never breaks. Click cloud and I hit tab again. I want to go project and then hit tab again. And I want to go to scripts. And I'm going to go. Oh, all right. There's an error. I see my error. Does anyone else see my error?
List.file instead of list.files.
Yeah, exactly. It's a typo. So I need an S here. Yeah, thank you, Neil. Okay, so list.files. Now I see everything in here. So this is a absolute path. So a relative path. So let's say in this example, so let's say I just want to go to project. And in project, I have these. So a relative path starts from where you are currently. So absolute path always starts at the root. So we want to go to project from where we are right now. So from our current working directory, which is scripts, we want to go back. So we want to go up the tree. So that actually takes you to use a very weird notation, is this double dot. Double dot or double period, open parentheses, should give you this. So double dot means the previous, the directory above you. Is that confusing? Does that make sense? Yeah. So let's do double dot and then another double dot, and let's see where that leads. So that is showing me project. So it's probably here at cloud. So it went up to directories. Does that make sense? So let's go to that document again. So if say I'm Larry and I want to go to users. So a single set of double dots takes me here. And then another set of double dots then takes me here. So that's what those two double dots did. Double dots did. And there, I don't start with a root. So root is not included here. This is relative to here, where I am right now. So what if I want to look to the next folder that's contained within scripts? So then I would just say home, and that would take me forward. And then if home contains stuff, then I can say this is a sub directory of home, and so on and so forth. Okay. Hopefully that made sense and didn't confuse anyone. And it might seem trivial right now, like, oh, why am I learning this? This is so boring. I get you, it is, but this gets really confusing as you start working with your own data in your own folder. So always check where you are with getwd, and then to navigate to different parts of your computer, you can use either an absolute path or a relative path. So if you don't remember it now, the material, I will put this link in the lesson notes, so you can take a look at it on your own time as well. Okay. I think I actually covered most of everything that I wanted to share with you guys today. So maybe we can do a few challenges. Let's see. Right. So we've done this. Done that, so we won't do this. But let's do this as a final challenge, and then we can look to wrap up today. So run the code from the previous challenge. So that's challenge 2. We can go back up. Ooh. So this is challenge 2. And you want to write a command that compares mass to age, that demonstrates, that asks the question, is mass larger than age? And when you're done, put your name on the document. Don't put the answer though. Keep that answer to yourself for now. And I'm putting together another challenge. Maybe if I do this, then you can still see. So I taught you guys how to, so for challenge 4, I showed you guys how to get to the help page for functions, right? So look at the help page for the function. This is the function. It's just the letter C. And figure out what it does and what do you think is going to happen. And based on what you read, try this out and see what happens. What does the output look like? So I haven't introduced this particular function yet, but I have mentioned what vectors are. So first hint is this is the help function. So we can run this and you should see this pop up. And I find that the most helpful part of the help function is actually at the very bottom where it says examples and it gives you a bunch of examples of how to use it. In this case, I don't know if it's actually helpful. You just have to try the code here to figure out what it does. Okay, we have 15 minutes left till 8, so let's just do this together. So copy and paste this here. So before I introduced like what vectors were, right? So it's just like this one-dimensional thing. So we can copy, run this code here, and it gives me 1, 2, 3. So this is a vector of 3 items, 1, 2, and 3. Before I did this thing, I can also create the same thing by doing 1 through 3. This will also give me the same answer here. But if it's not, continuous, that this particular example isn't very helpful. So we can do 1, 2, 6, 100. You can make a vector using this. So basically C kind of creates a vector for you of any item. Let's run this, see what happens. We see DEF. So I mentioned you can store characters in variables. You can also store characters in vector. And how you know it's a character versus a number is because it has these double quotes, or you can use single quotes. It's actually quite confusing. The single quotes and the double quotes are the same things in R. But remember, this is not a backtick, so by the way. This is a backtick and this is a single quote. They're different because one's slanted and one's not as slanty. If you squint hard enough, you could see it. But yeah, so single quotes, double quotes, that denotes characters. Okay, so let's do this last example. This is funky. Does anyone want to take a stab at what happens here that's interesting and that makes it different from this example up here?
It turns the numbers 1 and 2 into strings. Is that what's happening?
Yeah, exactly. The way you can tell, so strings are another word for characters. So thanks, Diana, for introducing that term. So we have numbers or integers, or we'll do floats another time, or you can have strings. So strings just mean characters. And the way you know that these are strings or characters is because the one is now surrounded by these double quotes. So if I were to do this, you could see these numbers don't have double quotes, whereas these ones do. So I can, run, arithmetic on this, but if I try to do the same thing here, it's not going to work because now R interprets 1 and 2 as characters instead of a number. And the reason why it does this is because there's a very specific rule in R for vectors. So vectors, this one-dimensional thing, can only contain one type of data. So it can either contain all numbers or all characters or all Booleans. So Booleans are, again, true, false statements. And they're always written in all caps, just so you know. So for example, it forces everything to be the same. So there's no way a character can be a number, but a number can be a character because you can surround that in double quotes. That's why this became a vector of strings, if that makes sense. So again, one data type per vector, that's what happens. And it doesn't, I don't know if this tells you, oh, here, it says the default method combines segments from all vector. All arguments are coarse to a common type and it's returned. So the help function, if you bother reading it, will tell you what it does. I never really quite read it. I just skip to the examples because I'm lazy. Yeah. And before we end, I want to share a really helpful place to look for answers to any coding questions that you might have. I don't need to introduce you to Google, but Google will give you a bunch of hits and most likely will lead you to a place called Stack Overflow. Okay, well, here's an example of something that I searched before. You'll get here and most likely someone would have asked the same questions that you had previously. I don't know what I was trying to search for, but Stack Overflow is your best friend. This website is quite reliable. If you scroll down, you can see all the answers and it's kind of upvoted by most popular. So the most popular vote typically is the correct one for the particular question. So take a look at Stack Overflow whenever you have any questions. Yeah, this is a really great resource. And I think that, especially in coding, copying code is a form of flattery, I think, because, someone wrote a code really elegantly, you want to use it. There's no such thing as citing this particular answer. It's just a common thing that people borrow code all the time. Yeah, so that's it for day one. Something that I want to share with everyone is this link here. how do I find? Can someone post this on the chat, please?
I need to find.
I found the window. Here it is. Hopefully, share anyone with the link. Great. I hope everyone has signed up for part 2, 3, and 4 of the workshop series, because we want to make sure that we're teaching in a way that makes sense for you, and that's easiest for you to follow. So typically, in a in-person workshop, I mentioned that everyone has these red and green stickies. We actually do have these sticky notes, and we want to kind of get your feedback on. I'm going to close this so you can type in private. What worked for you? So something that you thought worked for you, and that you liked about the workshop, put it in the green column. Something that you had trouble with, or couldn't figure out, or you think we can improve on, or I can improve on, you can put it in the red column. But if you could leave one note in each color, that'd be great. This is so that we can address whatever that needs addressing for next time. So if you thought, I talked too fast, you could say that, I'll slow down. Or the person who's teaching the next, who is Jasmine, who's teaching part 2, she'll make sure she talks slower than me, and she does a better job than I did today. So please leave a comment before you go. And if you haven't already, please sign up for part 2, because oh, I guess my screen's still shared. So this is part 1. If you go here,
Yeah, I've linked
and scroll down. Oh, you linked it? Great. Yeah, so there's part 2, part 3, and part 4. We're going to cover the rest of it. So like I said, we're taking this in like bite-sized chunks. This like 2-day intense workshop. We're breaking it up into a few hours a week. So it's every Wednesday at this time. So in the next lesson, you'll go through something much more exciting, which is
data frames and whatnot. Yay.
Yeah, data frames. This is awesome, because if you work in Excel and you don't want to work in Excel because Excel is has issues, and you want to be more reproducible, you want to be a fancy coder, this is part 2's going to have all the things that you don't want to miss. And it ends with ggplot, which is the most exciting part. So not to steal Jasmine's thunder, but look at these plots. Don't you want to make one of those? So if you do, you got to sign up for part 2. Anyways, great. I'm gonna stop sharing. Hopefully you can stop recording, Jasmine.
On that note, Yuka, really quick,
Yeah.
those duty plots are really, really great.